security researcher. Right now I'm with Open Security. Previously I was with CSPF, and I have spoken at CoCon, DEFCON Bangalore, DEFCON Kerala, and have recently been invited for TourCon as well as Hack in the Box. So my main areas of interest are embedded system security. I just recently got into it and I find it really interesting. So this talk is mainly going to be about embedded system security. Another field that captures my interest is RTL-SDR, or radio research. We'll also be covering that in this slideshow. Whenever I get free time, I also do a bit of malware analysis. It's more of a hobby. And I have a few open source projects on GitHub called Arcanum and PyTriage. One is secure file storage system, as well as the other is malware analysis framework. Me along with a few others organizing DEFCON gathering in Kerala called DEFCON Kerala. It will be on March 4th or March 8th. The date is a bit undecided, but if you check our website, you'll know. So registration is still open. CFP is unfortunately closed. I prefer to code in Python. You can observe that in my GitHub repository. And I've contributed a few open source projects like Conpod, as well as privacy enhancements you would call OpenFA. So that's enough about me. Let's get started. So why hardware? I mean, you have many other stuff. Like we have client-side exploits, remote exploits. We have web applications. We have malware. So why choose hardware? I mean, it's a bit conspicuous, right? I mean, it's difficult to hide, remote USRP or another software-defined radio. It's difficult to hide a dish antenna mounted on the top of your van. It looks kind of suspicious while you're driving through a neighborhood, right? So why use hardware instead of software? So, of course, hardware and software are not mutually exclusive, but hardware in this context would mean embedded attacks. So the reason I chose hardware for this talk, as well as hardware is gaining prevalence in the security community because of a few reasons. One is that it's more interesting. It's the interesting is it's just a view shared by some people. It's just that all of us have been exposed to software security in one way or the other, but hardware security is not well known among our community. So maybe it's a beginner's interest, but still it's a pretty interesting field. Another thing is that, as I mentioned before, it's not very well known in the security community. So you'll know how obscure it would be within the normal citizens of this area. So just imagine a building or secure office which has state-of-the-art intrusion detection system as well as security guards. A hardware attack, which would be described in the subsequent slides, would be more difficult to prevent than a purely software attack. So since it's less well known, it's also kind of hard to defend against because we have to raise awareness. It's also more rewarding like for example, the first time I got Raspberry Pi, I've been coding for around 3 or 4 years when I got the Raspberry Pi. So it's a different feeling when you blink your first LED, Up till then you're just building stuff, it has an impact, but the first time you make a difference in the physical world, it's a different feeling. There's also the other thing about, it's a very easy entry point into otherwise secure networks. I think it was in DEFCON 19, I guess, I'm not sure, but there was a talk on how a pen tester used netbooks which had a modified firmware so in the network card, so that whenever he plugs it into, it would be used as a drop-off netbook, he would drop it in the target network and someone would pick it up, plug it in, and the entire network would be compromised. So as I mentioned earlier, it's kind of easier to penetrate into organizations with hardware than it is with software. It is relative, of course, but mostly it's easier. Of course, it's really awesome. What would you be more interested in? Building a quadcopter that takes over Wi-Fi networks, which Dr. Phil Polster demonstrated recently, or remotely attacking a system. Both have equal or somewhat different viewpoints, but still I think hacking via quadcopter is more interesting than hacking via Metasploit or any other remote attack. So, can anyone recognize the building? Fort Knox. So, let's consider a building which is as secure as Fort Knox. I mean, no one goes in, no one goes out without permission. So let's take an example in which let's say there's a nuclear reactor which has an air gap network which you cannot get in unless you have a pass and you're screened constantly. Of course, since it's air gap, you don't have network access into it. So how would you get it? How would you insert a malware or some other system into it? Most of us already know the answer because it happened recently with the Natanz power plant. We use a drop-off device, maybe a USB, maybe an HID device disguised as a USB, whatever it is. Sometimes dropped-off hardware can prove to be more intrusive than a software package. So, what is actually covered in this presentation? Let's just take a look. We will be covering HID attacks. This HID attacks are basically attacks that simulate keyboard and mouse presses. So your keyboard and mouse are actually HID devices. It's a class, human interface device. So we will be seeing how we can simulate devices for getting maximum penetration into an organization. Then there is the infrared vector. Infrared is not as, let's say, as important as the radio vector, but still it's a very interesting vector because it's not analyzed or it's not constructed with security in mind. So we will mainly be covering how to attack pedestrian services as well as pedestrian lights, as well as TVs and other gadgets that use infrared. Recently I came to know that some cars have started using infrared for their locking and unlocking systems, even though that has more security, but I'm not sure how valid that information is. Okay, so radio. The first thing you think about when you hear radio attacks or wireless attacks is that it's Wi-Fi. It's not. Wireless is not equal to Wi-Fi. There are a lot of wireless vectors. You can attack cars entry, like keyless entry system. You can attack satellite, which has been demonstrated recently. You can attack ships from the landmass. You can attack aircrafts using, overtaking their air cars or other systems that are online which use radio. So radio attacks are another field that does not get the scrutiny that it deserves. Then we have something else called the bus attacks. See, all these electronic devices need to communicate with each other. So to communicate with each other, they use electronic buses, and all these electronic buses have pre-established protocols in most cases. In some cases they're proprietary and we won't know about them, or in some cases they develop their own custom protocols, but mostly they use protocols which are well known and easy to sniff. So they don't actually protect the buses because, see, when you're designing a product, you don't actually expect the normal customer to open up his router, plug his bus pirate into the debug points and just get the firmware out. That's not something that is in the normal threat analysis. So the usual suspects in any penetration scenario are this. You have wireless LAN attacks, maybe you get it through web application, maybe through the client side, and maybe even more, remotely, maybe the remote exploits. But no one suspects cases Soze. You've seen the usual suspects, right? So no one suspects cases Soze. The hardware attack is, in most cases, the most damaging or the most debilitating attack. So let's take a look at infrared attacks first. So what is infrared actually? It's a spectrum of electromagnetic waves. Sorry. So infrared waves are light waves, but we can't actually see them because our eyes are not accustomed to that wavelength of light. So for that reason and for other reasons, infrared communication is used in a variety of situations. Earlier on, how many of you have had phones that communicated using infrared? Long time back, not long. So it was quite popular when they introduced it. My first phone had it 5200, but right now it's not a very popular thing. But there are also other devices that use infrared a lot. One is TVs. Everywhere you go, TVs use infrared. Rarely do TVs use radio because infrared is much more economical as well as its line of sight. So you don't have to worry about your neighbor changing your channel unless they use some attacks, which we'll describe. So, infrared is used in TVs, and this another fact that is not as well known is that infrared is also used in certain traffic lights. It's only established in some parts of the world, maybe some streets of US. It's basically a system used by ambulances to change the color of the traffic lights when they pass through. So devices are available legally that will simulate the ambulance's lights so that you can pass through the traffic lights with ease. Like everywhere you go, it will be green lights. So this can be simulated. This is an attack that uses infrared. So the thing about infrared is that the infrared communication has certain protocols. So there are four chiefly used protocols, three chiefly used protocols, and then there's the fourth category. The protocols are Philips, Sony, NEC, and then you have the raw transmissions. So the thing is, most of the remotes that you get like this, for Chinese devices, it will most probably use an NEC standard for emitting infrared. Sony TVs will use Sony, but some other Chinese devices also use Sony. This is why when you lose a remote, if your remote stops functioning, you take it to a person and then he gives you a remote which looks different but will perform the same functions. It's because they use the same standards so that then the new remote and the TV can still talk to each other. So infrared is comparatively easier to work with than the other vectors, the other attack vectors that we described here, because there's already an infrared library that exists in Arduino, and it's written by Ken Sheriff. In most Arduino installations, it's already an inbuilt thing, or you can download and install it if you want. So the infrared library, which is already available, has a lot of modules which can be used as an attack module. So let's take a look. So what exactly do you need for this attack? This is something we're going to be covering a lot in each of the slides, because each of these attacks, since they are hardware attacks, there are some prerequisites, some software that you need, and of course there are some hardware that you need. Unlike software attacks in which you just need to download something and use it, you'll have to purchase this and then you'll have to make sure it works. And most of the time, you'll spend your time scratching your heads because you forgot to connect two pins. Because I didn't sleep yesterday because I thought my teensy, that's the microcontroller I'm using, is not working. Then I finally realized at 5 in the morning that I had misread the labeling on it, and it was a teensy 3.1, not a teensy 3.0. So that kind of happens a lot when you're dealing with hardware. So let's get started with infrared, right? So what exactly do we need for infrared? So if you're thinking about a system, if you're attacking a system, how do you attack a system? First you need to actually communicate with the system. You need to emulate something that is already communicating with the system. So in this case, we can use two things. For transmitting, we use an infrared LED, which is commonly available, and then you can use an infrared receiver for receiving data. Both of these are commonly available in electronic shops. You just need to ask for it. I recommend the TSOP382 infrared receiver because it's much easier to work with, and the Arduino library is already, the Arduino library is already created around it, so you don't actually have to change anything. But yeah, right now for this I'm using a low cost one. It's called an SMA SM0038. It's a Chinese version of this, but it has some problems. It has a slight jitter, so it's not as accurate as a piece of 382. Okay, for transmission we have infrared, and you just need to have a little mischievous mind. Okay, sorry, I forgot. Just having the infrared transmitter and receiver won't help. You also need a microcontroller or a controlling logic to send and receive the data. A Raspberry Pi or a BeagleBone Black would be overkill in this situation, because the only thing you're doing is receiving and transmitting. There's no DSP, there's no processing involved, so just receive and then transmit. Okay, so let's get started. So what's the first attack that you can think of in infrared? Or any other communication attack, the first thing that everyone thinks of is replay attacks, right? Replay attacks are what? You receive a data, or like if Alice is sending something to Bob, Melissa intercepts Alice's communication and then sends it to Bob at a later time. So that's replay attack. So some systems like cars key fob systems or keyless entry systems have protections against replay attacks. They have something called rolling codes that we will discuss later on. But infrared systems, most infrared systems, does not have any sort of protection, because well, if you think about it, any security that is being implemented would require an extra cost, and it is not necessary for a TV to have a rolling code. If you think about it, it will just further complicate the situation. So maybe that's why infrared does not have like the infrared that is implemented in TV does not have a rolling code system. Also, in case of the pedestrian control systems, as far as I can see, there was no rolling code system. So the replay attack works by capturing the infrared data and then retransmitting it whenever you need. So this is a sample of that. I actually have an implementation here which is using a different microcontroller called the Teensy. But if you have an Arduino and if you have a receiver as well as a infrared receiver as well as transmitter, you can build this very easily. Then you have something fun called the TV Beacon. It's a DIY package. You can build it yourself or you can buy it. What this does is that, remember the codes I mentioned like Sony, NEC and Philips? So all of these systems have an off code for TVs, and it's a switch on and switch off code. So what it does is that in the small microcontroller that you see in the middle, all the off codes of all the TVs are imprinted into it. So the moment you press a button, it sends off all the off codes of all the TVs in a sequence. So what happens? You just go to a big TV shop, or even if you go to Times Square, wherever the TVs have an infrared control system, you press the button, all the TVs in that area are switched off. Now this might seem like prank, but in certain cases like CCTV systems or certain systems which are CCTVs which are implemented incorrectly, which uses TVs which can be switched off like that, it can cause problems. So let's have a demo. Okay, this is how I've done it. This is a Teensy 3.1. It is the microcontroller that we're using, and we have an infrared receiver here and an infrared LED over here. I'll try to show using my cell phone, but right now let's just get started. Okay, so see, this is what I was talking about. Right now, see all these received unknown codes. This happens because the infrared receiver that I'm using is not of good quality. So now if I press my switch, my remote, we are doing is we are actually communicating with the DNC through a serial connection. Okay, so these are the inbuilt examples inside the Arduino library. So we're using IR record, and I just changed the button pin to 2. So this is pretty simple actually once you read it. So this is just enabling the serial circuit and then enabling infrared. Then we are setting the button pin as well as the status pin. Once that's done, this is all code so that it first receives the signal using the infrared receiver, then it stores it. After it's stored, when it receives itself, it can know whether it's an NEC signal, a Philips signal, or a Sony signal. So, or if it's a raw signal, it's stored accordingly. And then it waits for the button press. There's a button which I've added to the circuit. So it waits for the button press, and once the button is pressed, that is a problem. The receiver I'm using is slightly low quality, so these received unknown codes are actually jitter from the circuit. But if you look carefully, while I'm pressing, you can see something called received NEC. That is the code that is actually being received. If you're using a higher quality receiver like the T-sub 382, this problem won't be there. So anyway, just look for the received NEC code. So that is what happens when I press this button. The NEC code for power off is actually received by the DNC microcontroller and stored. And when I press the button, after pressing NEC, it will send that data. Okay, so now you can see it's sent raw because just before I press the button, that jitter came back again. But if this were in a non-jitter circuit, it will send the signal that it received from the previous device. So an attack that you can use is in a scenario in which you can use is maybe a system which uses infrared as authentication. You can place this device just in the area or within the line of sight of the receiver, and then you can add a power source so that it will wait for an infrared signal, and then it will store it. And once it's received, you can then use this device later on whenever you want to access whatever authentication that access whatever device that had used it before. Yeah, sure.
Regarding infrared, you said regarding the car infrared authentication, but for any kind of authentication, the cars are using different chips which are generating random numbers.
Yeah.
So basically, in getting an infrared or getting that radio signal also doesn't help us.
That's what I said. Rolling codes are used in cars. That's for radio. The infrared one, that I actually did not get from a very, I could not confirm that. I'm not sure cars use infrared, that's what I mentioned before. Cars, I'm not sure they use infrared. I heard it from source that they're trying it out currently. As for radio, you're correct, they use rolling codes. So if you capture one, then you can't use it for the next one. So this is how you use a replay attack in infrared. Okay, so TVB gone, as I mentioned earlier, you can purchase it over you can actually make it with an Arduino. Right now, since we don't have much time, we're not demonstrating the TVB gone attack also. But basically, it is a microcontroller which has a list of the opcodes of all infrared devices stored into it, and then when you press the button, it just replays all the opcodes. Okay, now the next attack is a bit more interesting and it's very devastating. The HID attack, it works like this. Imagine you're sitting in front of a system. Like if you have physical access to a system, that system can be considered compromised, because in most cases, if an attacker has physical access to a system, he can do whatever he wants with the system. Let's say the person who's the owner of the system is very security conscious and has enabled full disk encryption as well as a BIOS password. So that would actually prevent a lot of software attacks and a lot of physical attacks. But still, if the person is able to install a keylogger on the system, he will be able to get down the sign-on password as well as the BIOS password, and he will be able to use it for decrypting the device later on. So,
Yes, not understood. How would the keylogger capture the BIOS?
Hardware keylogger.
BIOS is before the
hardware keylogger.
I said not understood how a keylogger would capture the BIOS password.
Yeah, the BIOS password is typed in with the keyboard, right?
No, but it comes into play much before the operating system comes in.
Yeah, if you're using a hardware keylogger, see, if you're using a software keylogger, the software keylogger would only run when the operating system runs. But if you're using a hardware keylogger, which is connected to the PS2 or the USB port of the laptop, of the keyboard, then it would capture it, and you can actually design this. The head of Iron Geek, Adrian Crenshaw, has actually created a keylogger that would store all the keylogs to micro SD card. It's basically a small teensy device to one side which you can connect.
That to work, you need to modify the BIOS also.
No.
Not
You
actually.
Actually, you can have one device already. You can get the keylogger like this, and it would work without modifying anything in the PC. So this is PS2 keylogger. If you want to see.
So it's basically you are reading communication between hardware communication between the keyboard and the computer. So the OS does not come into play. So all right. So this was what I meant, like hardware attacks. This is a demonstration of an HID attack. It's not exactly a HID attack. So HID attack, frankly, would be something that uses a simulated HID device. A keyboard or a mouse are HID devices. So let's say an attacker has access to your system via a keyboard. Now this is quite devastating because he can enter whatever command that you have, and it would be run within whatever context the user is currently running in. So of course this is in a system where the user is not logged out. If he's logged out and he's not able to enter anything, this won't work. But this is an attack which would work really well in a drop-off scenario. A person would drop off a device, and that device would actually gather information, insert keystrokes into the system while the other person is not watching. So how exactly would this take place? Just imagine some person typing Control-Alt-T. Let's imagine you have an Ubuntu machine. Just imagine a person coming and typing Control-Alt-T and then typing in a netcat command which would maybe launch bash and then connect to a remote server, or start a listener in the current server so that anyone can connect. So this can be done within what? Control-Alt-T as a sequence plus ncat -listen and -e, whatever the sequence for a listening shell on the system is. So this is just 2 lines of code that needs to be tied into a system. So what if we can save that 2 lines within an HID device, an automated HID device, and whenever a user plugs in this device into the system, this is automatically executed. Now this is a very, very simplified version of it. There are frameworks that will do it. Let's take a look. So initially we had the initial HID attacks were done using 2 things. There were 2 providers for HID attacks. One of them was the USB rubber ducky. Hat5 actually developed this attack. It is basically a microcontroller which has an HID interface, and they give it a very good packaging too. When you see it, it would appear as if it's a USB device. So what it does is that when you plug this in, the code that is already there inside the system starts to run. So Rubber Ducky actually has an inbuilt, like when you buy it, you have a scripting language that comes with it, as well as a GUI interface. So you can choose the script that you want to run later on, and that script will be burned into the memory of the Rubber Ducky. So right now we don't have a Rubber Ducky, but we do have a Teensy device. Sorry. Yeah, we do have a Teensy device, so which performs the same function. So Teensy is developed by BJRC. It's an Arduino clone, which means that you can do whatever an Arduino can, and you can program it using the Arduino IDE. So it can emulate an HID device, as in it can act as if the current device is a keyboard. It can act as if the Teensy is actually a keyboard or a mouse. So there are existing tools like Kautilya as well as Social Engineering Toolkit, which utilize these attacks to create custom payloads for Teensy. So Kautilya is a framework developed by Samrat Ashok, who actually created the tool so that you can create custom payloads with your custom server as well as a custom command that needs to be executed. So it's all very easy to use. The only thing you need is to provide the name of provide the IP or the host name of the server that you need to connect to for the payload, as well as the exact command sequence that you need if you need to customize. There's a default command sequence, and once that's done, it gives you a shell code which you can then burn it into the Teensy. So the next time someone plugs in that Teensy into a computer, the shell code that you have generated, it will automatically run over there. So this is also multi-platform. The same device can be used for multiple platforms, but you will need to slightly change the code. So as an example of how a shell code would run, I mean what a shell code is in with regards to this. One of the shellcodes of Kautilya is in such a way that the moment the user connects the device to the system, it starts up a command shell. Then from there it echoes certain commands and it uses the echo command to create a shell script, a PowerShell script. So this PowerShell script is then made to run on a periodic basis using registry keys. So what happens is that this PowerShell keeps on running every time the user logs in or every time the system gets restarted. So these are not really detected by most antivirus systems. Last time I checked, it was not detected by any of the antivirus systems that I've used. So this is mainly due to 3 or 4 different reasons. One is that no one actually, this is not something like an autorun.inf attack. In a normal autorun attack, it's the system knows that something has been run automatically, or even if it's an LNK vulnerability attack also, if you have a good heuristic system or if you have a good antivirus, it will know that something has been executed automatically, or there's something wrong somewhere, because it's not done by the user. It can say with sufficient certainty that this has not been executed by the user. But in case of HID attacks, the system, let's say this is a security system, that system cannot actually differentiate between what the user typed in or what the Teensy has injected into the system. So this is why HID attacks are so powerful. HID attacks are also really important in another context, because recently there has been an attack that used HID to exfiltrate data. So now this is actually very interesting, because HIDs cannot actually read data from the system. Like technically they cannot read files or they cannot even read keystrokes, because the only data that is sent from the system to the HID, there's only a small amount of data sent from the system to the HID device, and some of them are the caps lock flag, the number lock flag, as well as the scroll lock flag. So recently a security researcher created a script so that he would toggle the number lock and the scroll lock in such a way that it would take a data, it would convert it into a form that can be expressed in number lock, scroll lock, and caps lock flags, and he would alternate between them in such a way so that the HID device would get the data and store it in an internal medium. Another thing worth noting is that the internal memory of these systems, HID devices, these are mostly microcontrollers, so they don't have much memory. So you will need to add, if you need to have a payload that is, let's say, more than 16 KB, you would need to attach micro SD or an SD card module so that it can read data from the module and then copy it to the system. Okay, so let's take a look on how HID attacks are done. Again, we're using the TNC. Now, Kautilya has a lot of payloads for TNC. So you can actually choose different payloads. You can choose whether it's a payload for Windows, for Linux, or whatever it is. You can, when you choose payloads for Linux, you can see what all payloads are available. See, as you can see, it's a pretty diverse payload option. You can choose whatever suits your scenario. And the thing is, in case of Windows, it's very easy recently to create a PowerShell payload. Now, PowerShell, for those who don't know, is a scripting framework for Windows, which is actually very useful for system administrators as well as penetration testers. PowerShell has the ability to call any system function, a .NET function, with ease from within the script itself. So this makes sure that you don't actually have to create a payload, a .NET RAT or a .NET payload which would call all these libraries, because you can actually call these libraries from within PowerShell itself. Okay, so before you actually, Kautilya actually outputs the payload into a hex format, like .ino format, which is actually the Arduino IDE's default file saving format. So one thing you need to make sure is that your USB type for the TNC is set to serial plus keyboard plus mouse plus joystick, or keyboard plus mouse plus joystick, or anything that has keyboard in it. Now once that's done, let's just take an example. Now this would actually what this does is that it prints hello world and prints the number 1. So as you can see, it keeps on printing this, and this is basically how an HID attack works. Now convert this into a real world context. Imagine that instead of hello world, the HID is actually simulating run command plus, like that's Windows plus R, but if it's in the case of Linux, it's control plus Alt plus T. So the thing is, HID attacks can be very hard to prevent. The main reason, as I mentioned earlier, is because it is difficult to differentiate an HID, like an HID device that is working autonomously, from a person who's sitting there and is typing it in. now this is kind of my most interesting topic that I'm researching right now. So radio has a bad rap, or it doesn't have a rap at all. I mean, not every, in the security community as well as in the, mainly in the security community, radio is not given the focus or importance that it needs. Like I mentioned earlier, cars use radio for locking and unlocking. Yes, they do have rolling codes. Well, actually, they're supposed to have rolling codes. But recently, it has been discovered that certain cars, mainly those manufactured in China or where the ECUs are manufactured in a certain factory in China, I believe, do not have rolling codes, which means that they're using the same codes again and again. So, really, what they should have, in most cases of the cars, they have a rolling code system, which means that when you press a button, it sends a signal. But when you press the same button again, it does not give the same signal, it gives a different signal. And the client and the server in this case, which is the car's unlocking system and the key fob, have an understanding so that they can recognize each other even if the sequences are out of order. So for knowing more about this, for researching what it is, you need to have some sort of a system which would actually receive the data. Now, receiving radio data was not technically possible without very expensive equipment. Previously, you needed something like a USRP, which would cost around $2,000 for working with these devices, mainly because it's a very expensive device to make and manufacture. So ETS Research had something called the USRP, and there was some other USRP products offered by other providers too. I believe it was NI Systems. But the thing is, it was very expensive to research in the radio field. But recently, researchers found that the TV tuner cards that are available, this is DVB2 TV tuner card. It has an R820T chipset. So the thing about that is that these were actually designed for receiving TV signals from the air, like DVB-T signals, which means terrestrial signals. But the researcher found that the USB interface actually exposes everything from 27 MHz to 1700 MHz in certain systems, and in certain other systems they have a different range. But the thing is, you can receive a lot within this range, and the most important thing is that these things are dirt cheap. You can have one for $20, and there are even some which you can get for $10. So earlier, while you had to pay $2,000 just to receive some radio information, using these you can receive any data between the mentioned spectrum for $10 to $15. So this technology is known as RTL SDR, where SDR stands for Software Defined Radio. So what can this do? You can actually listen to aircraft communications, ship communications, and if you actually use it properly, if you have actually set it up properly, you can even intercept GSM communication. But that actually has legal implications. Plus, in certain places, GSM is encrypted, of course, using the Kasumi encryption. But even that, if it's not encrypted, it's very easy to capture GSM data. But even if it is encrypted, research by researcher Carsten Nolan, which was showcased in the Chaos Congress Club, showed that you can actually decrypt the data using a 2 TB rainbow table. So once you have that rainbow table, you can decrypt any GSM communication, provided you have access to a device such as the RTL SDR or the USRP. So if you're thinking of buying an RTL SDR, just make sure you have you choose the correct one, because there are two types of chipsets which are there in the RTL SDR. All of them will have different names. This is the new elect RTL SDR. Then there are others, Teratech and Huawei's. So these things, make sure that you choose the correct chipset some of these will have similar chipsets. So the most common chipsets are Elonix E4000 and the Realtek R820T. So this one is the most commonly available SDR. This is the Nuvalec R820T DVB-T. So this one uses the R820T chipset, and it can receive anything between 24 to 1766 megahertz. The E4000 would allow you to receive anything between 52 to 2200 megahertz. So the thing is, you can even use it to receive satellite communication, even Ku-band and Ka-band data. So even though this SDR does not have frequency ranges in those regions, you can use an LLM convert that, like, see, for example, the U2 moon rover, which is the rover of China, which is currently stationed in moon. It, if I remember correctly, it has a downlink frequency of around 6 gigahertz, 6 or 10, I'm not sure. But that we can use an Avenger LNB antenna, an LNB, to down convert that into 800 megahertz, and then you can feed that to the RTL SDR so you can read the telemetry data. This can also be done for a variety of other platforms. You can even get information like telemetry information from some hobbyist satellites. And there are others also. There are other implications of RTL SDR also. So you can actually, the flow chart of working with that RTL SDR is like this. You find what the communication is, you find which communication you want to analyze, you put that into the software which would give you a graphical representation, and then you find out what type of modulation it uses, and then you would have to convert it into a data format. So for this, of course you can't do this manually because these all are processor intensive applications. So you can use there are a lot of software that is available right now for these purposes. So GQRX is one of them, and mainly for working with any other device, for any other software. If it's in Linux, you need to use RTL_SDR package. This is a package that allows you to communicate with RTL SDR devices. And SDR Sharp is a software package that is available in Windows, which allows you to communicate with RTL SDR devices. It also in some distributions, it also has the ZDIG drivers, ZADIG. It is the drivers in Windows necessary for communicating with the SDR. So once you have those, you can actually open up SDR Sharp and get a complete representation of the radio data around you. Now, how you decode that? Now that is up to you, because it requires a lot of knowledge, because you need to understand radio basics as well as how it works and like how transmission works, what are the modulation, stuff like that. But a person who has a ham radio license would find it very easy. So what can you actually get with this data? I mentioned some use cases, but there are some other things that you can actually get with this RTL SDR. One is AIS, which stands for, it is mainly for ship transmissions. So it will tell you what exactly the ships are. These are broadcast by ships to follow certain regulations. So AIS transmissions would allow you to pick up ships' locations as well as what their current status is. So similar to AIS, aircrafts have something called ADS-B, which stands for ADS broadcast. So ADS-B is also similar to AIS in that it's not encrypted, and it's actually free for all. Anyone can listen into it. Usually there were already devices that allowed you to read this earlier, but those were very expensive. But now any person with $15 can listen to these frequencies. So ADS-B actually works in the 1090 megahertz range. AIS was in the 161.925 megahertz range. So you can use the SDR to listen to communications in these frequencies. Borderline is a tool that is there in Linux. It is possible to use it in Windows, but it's very difficult to set it up. So Borderline can be used to actually analyze what type of data is going on. It will actually show whether it's an FSK or some other modulation that's being used. So you can know the keying, the modulation mechanism and everything by looking at the data. So what are the possible attacks that can be done using RTL-STR? So I already mentioned car key fobs, that they're supposed to have rolling codes, but recently the research showed that not all cars have rolling key codes. Instead of transmitting codes that are different from one to the other, there are some of the cars have case in which the same key code keeps on repeating. So this is obviously a security vulnerability. And home automation systems, almost 98% of the cases, you see systems in which when a person comes to his front door, the front door slides about so that he can move his card. So, and in those systems as well as some other home automation systems, some remote, remote security systems, these don't actually use encryption or rolling codes or any of the normal security features. So these are also very easily sniffed using RTL-STR. So the thing with RTL-STR is that it can only receive. If you want to actually transmit the data, RTL-STR does not have the hardware for that. For that purpose, you can use a couple of things. One is a USRP. As I mentioned, it's very expensive, but thankfully right now you have three other options. One is to use Blade RF, the other is to use Hack RF. Both are SDR modules which allow you to transmit and receive as well. But the thing is, only Blade RF is currently available in the market right now. Hack RF has just successfully completed its Kickstarter package, and if you need to get it, you'll have to wait for a while. But both of them are in the semi-affordable region. For around 20,000 to 40,000 rupees, you can get one, while the USRP would cost around, well, it will be in the lakhs region. So, as I mentioned, for transmitting, you need all these stuff. But the thing is, if you get a Hack RF or a Blade RF, you can transmit in any frequency range in its very vast frequency range. Like you can transmit from anywhere between 300 megahertz to 3 gigahertz in the Blade RF, and in case of Hack RF, you can transmit up to 6 gigahertz. But the thing is, you don't actually need all that bandwidth in some cases, because home automation systems almost always use 433 megahertz as its default security frequency, and otherwise some use 918 megahertz as its frequency range. So the thing is, you can actually use these you can actually use transmitters that are easily available in the market for this. So there's a project called RFCAT which actually implements this. Okay, so I'll go fast, I'm a bit low on time. So antennas. See, the main thing about working with RTL-STR is the antennas that you use. So you have to use different antennas according to what you actually want to receive. So you have to use a monopole antenna if you want to receive stuff like ACARS, ADSB or AIS. Double ducky antenna. I'll show you the double ducky antenna if you have the time. It's a small one which you can bend for Motorola walkie-talkies. Those are bent-T antennas. So for short range and for portability, use rubber ducky antennas. And if you want a wide range of frequencies, use a discount antenna. So these are the different antennas. That's the middle one is a monopole with 3 axials. Okay, for demo I actually have to restart my system, so I'll show the SDR demo after the other demo is done. So bus attacks. So the bus is something that is used in the system. So the buses, electronic buses, have something like they are a means of communication for different devices. So the main bus protocols that are used are SPI, I2C and UART. So I guess most of you have an electronic badge. So these microcontrollers actually communicate. See, if there is an RTC on this, which is a real-time clock, or if there is an EEPROM on this, it would actually communicate with all these devices. The microcontroller would actually communicate with all these devices using these bus protocols. So all these protocols do not have an authentication mechanism. They actually just use addressing. I2C utilizes addressing, so it can know like which device to communicate with. So even these addresses can be actually be brute force. So you can actually communicate to an I2C bus and figure out what all other devices are there. So these are the main ways in which you can attack bus protocols. Sniffing. Sniffing is basically you put two plugs into the bus lines. You can use logic analyzers, alligator plugs, and then you can use the bus bars or network routers that you use actually have common hardware. Like the D-Link router that you use is actually quite similar to the Netgear routers. The only thing the slight difference will be in the firmware. So for this reason, the manufacturers keep the firmware proprietary, or sometimes it's very difficult to analyze the firmware. So in those cases, one way to get the firmware or to meddle with the firmware would be to actually access the router or any other device through the debug ports. So there are multiple debug ports. One of them would be UART, some of them would be JTAG. So for all of this, you can use a bus pirate. There are also other devices which you can use to communicate with buses, but personally, I prefer the bus pirate. So this is a bus pirate. So you can read, write in any of these protocols, I2C, SPI, UART, and even one-wire and button protocols. It also has a JTAG support. You can use it for JTAG, but you'd be better off buying a JTAG programmer. You can even use it to program AVRs, and recently it also has added PIC programming capabilities, but it's only PIC 16F, if I remember correctly. So you can actually connect to the bus pirate via USB, and from there you can choose which protocol that you want to use. Unfortunately, I'm out of time, so I can't show you the bus pirate. But if you come to me after this presentation, I can show you how the SDR works out. So thank you.